Today we're going to travel back to section 1.2, and we're going to deal with the rational equations that we kind of skipped over. We did linear last time. Now we're going to go back and deal with those rational equations. So rational equations, you definitely want to get rid of that denominator. So back when we did the linear equations, if you had, like, let's say for instance, here, let me put it on this page. If you had, for instance, 1/2 equals x over 4, right? If you had that. My advice is to multiply by your least common denominator. So here, I would want to just multiply everything by 4, because what you would have is 1 times 4 is 4 over 2. And 4 times x is 4x over 4. So we multiply both sides by 4. Notice what happens. All right, 4 over 2 is 2. This cancels. So it cancels out all my denominators. So if you multiply by your least common denominator here, you can actually get all those denominators to cancel out. So using that in rational expressions, equations, sorry. Let's think about our least common denominator here. So we got 2x, 18, and 3x. I know 2, 18, and 3x, we can use 18, because 18 is divisible by 2, 18, and 3. And then again, you got to use that x. So if you multiply both sides by 18x, your denominators should cancel out for you. So I'm going to write it like this just so you see. So we're going to multiply by 18x, still over 2x. Here we'll do 17. I'm going to leave it as 18x. We're not going to do any of the math because some stuff's going to cancel for us. 1 times 18x is 18x over 3x. And in this next step, all of my denominators should cancel. Cancel out that 2x. You're left with 9. So 5 times 9 is 45. Cancel out the 18s. You're left with 17x. Divide by 3x. Divide by 3x. You're left with 6. And now you're left with a linear equation. So you can add 6 to both sides. So you got 51. And divide both sides by 17. So you got x equals 3. Now, I will warn you, you'll always want to be honest, we should have done it before we started the problem, but you always want to look at the restrictions of your domain. So when you're looking at this one, remember x cannot equal 0. So always go back, check your domain, and make sure that your answer is allowed. Your answer is allowed. It's not one of your restricted numbers, which in this case we're good. So moving on. Next example, again, when we look in that domain, x cannot equal 0. So at the end of my problem, I want to refer back to that and make sure that x did not equal 0. Let's see what we need to multiply here. I got a 5, a 2, and a 1. So we're going to say 10, because 10 is divisible by 5, and 2, and 1. And then we got to use that x. So we're going to multiply everything. So we got 10x over x. We got 10x over 5. And we've got, again, I'm going to leave this because stuff's going to cancel. So I'm going to leave it as 3 times 10x over 2x. So here we got 10. Here we've got 2x, right? That divides. Here, divide by 2x, divide by 2x, you get 5, so plus 15. And again, it becomes that linear equation, which is much easier to work with. So subtract 15 from both sides, divide both sides by 2, and yes, fractions are fine, just leave it, -5 divided by 2. And we're good because x cannot equal 0. That is not 0, so we're good. So always go back and double check your domain. They do get a little bit harder. They do get a little bit harder. So in this next one, think about what you have to multiply by. So we're definitely going to need that 3. And we're definitely going to need that x minus 2. So we're going to multiply everything. So we got x. We're going to multiply it by 3 and x minus 2 over the denominator. We got a 2. We're going to multiply it by 3 and x minus 2. Still the same denominator. And here we've got a 2, and again we're going to multiply it by 3 and x minus 2. Again, I don't distribute anything because you should have some really nice things happening here. Here you got your x minus 2's cancel out. You got 3 times x, 3x. All right, no more denominators. Here your x minus 2's cancel out. You got 2 times 3 is 6. Here your 3's cancel out, which is still fine. So you'll have minus, and we'll go ahead and distribute this. 2 times x is 2x, and 2 times negative 2 is negative 4. So we're going to go ahead and distribute that subtraction. So we have minus 2x, and minus negative becomes plus 4. Add 2x to both sides. 6 and 4 make 10, combine like terms. Divide both sides by 5, and you get x equals 2. I forgot the domain again. So we're going to look back here, our domain. We know in the beginning x cannot equal 2. So there's our domain restrictions. And you look down here, x cannot equal 2. So in this case, that was the only answer we got. We have no solution. No solution. Be that null set. So again, make sure you always look back to your domain. Make sure you always look back to your domain. Here, x cannot equal, we know 5 and negative 5, plus or minus 5. So again, we're going to look back there at the end and make sure that x does not equal 5 or negative 5. Remember, x squared minus 25 is x plus 5, x minus 5. So it looks like that's what we need to multiply by. X plus 5, x minus 5. So here my x plus 5s will cancel, so I'll have 4, x minus 5. Here my x minus 5s will cancel, so I'll have 2, x plus 5. And here all of it will cancel, I'll be left with 32. And you'll start seeing the shortcuts where you don't have to draw this out and cancel them. Distribute 4x minus 20 and 2x plus 10. And combine your like terms. We got 6x's minus 10 equals 32. Add 10 to both sides. And divide by 6. Again, go back and check. X cannot equal 5 or negative 5, so we're good. All right, that is our answer. And last but not least, so this one gives you 2 equations. All right, consider the 2 equations. It says find all values for x where y1 will equal y2. So if y1 equals y2, then all of this should also equal all of this. So 1 over x plus 4 and 1 over x minus 4 should equal 22 over x squared minus 16. Again, remember x squared minus 16 is x plus 4, x minus 4. So it looks like to get rid of those denominators, we're going to have to use an x plus 4 and an x minus 4. So here the x plus 4s will cancel out. You'll be left with 1 times x minus 4. Here the x minus 4s will cancel out. You'll be left with 1 times x plus 4. And here the x plus 4 and the x minus 4 will cancel out, so you'll be left with 22. Combine like terms, 2x, negative 4 and 4 make 0, equals 22. Divide by 2, x equals 11. Again, when we looked at back in the original, we knew x could not equal plus or minus 4, which it doesn't in here. But this also does say check, so we want to go back and check our answers as well. So let's plug it in. 11 plus 4 is 15. 11 minus 4 is 7. Has to equal 22. I know this is x plus 4 times x minus 4, so I know it's 15 times 7. And if I'm trying to do this without a calculator, I'm just going to leave it like that. And again, I know to get rid of those denominators, I'm going to have to multiply by a 15 and a 7. So here the 15s will cancel out, 1 times 7. Here the 7s will cancel out, 1 times 15. And here the 15 and the 7 will both cancel out, 22. 7 plus 15 is 22. My answer works. All right, that's it for today. Bye, guys.